Good morning and welcome to our Alaska Collaborative on Health and the Environment teleconference on climate change and the release of contaminants in the Arctic, current research and potential health effects. And I just want to thank all of our speakers and all of you for joining us on this Monday morning. We typically have our calls on Wednesday, so thanks for your flexibility. We really appreciate that you're here with us this morning. My name is Diana DeFazio, and on behalf of Alaska Community Action on Toxics, I'll be facilitating today's call. CHE Alaska is a regional partnership group of the National Collaborative on Health and the Environment. CHE Alaska aims to advance knowledge and effective action to address growing concerns about the links between human health and environmental factors. You can find more information at akaction.org and healthandenvironment.org. We have 4 presenters today: Lars Otto Ryerson, Dr. James Berner, Merle Apasingok, and Vai Wahi. Dr. Berner will be using presentation slides. You can find a link to his presentation on our homepage at akaction.org. I will introduce each of our speakers individually before they present, and we will leave some time for discussion and your questions towards the end of the call. Now it's my honor to welcome and introduce Lars Otto Ryerson, who is joining us today in our Anchorage office, having just traveled from Norway for the Arctic Council meeting in Anchorage. Lars Otto Ryerson is a marine biologist by training, now working as an environmental scientist in Norway. He has served as the Executive Secretary of the Arctic Monitoring and Assessment Program, or AMAP, for over 2 decades. AMAP advises the governments of 8 Arctic countries on issues relating to threats to the region from pollution. In 2012, Ryerson received the Society of Environmental Toxicology and Chemistry's prestigious Rachel Carson Award in recognition of his important work to understand how human activities affect the fragile ecosystems in the Arctic. Welcome, Lars Otto. You may go ahead and begin.
Thank you very much. Thank you for inviting me to come to see you here in Anchorage and to speak to you. As you may know, and as you just said, AMAP has been working with the Arctic and the pollution of the Arctic for more than 20 years. And we have been focusing on seeing the effects of the pollutions on the ecosystems, the fish and the animals, and on the humans living in the north, especially those living off the traditional diet. We have been following chemicals coming from industry, from agriculture, that has been mostly used at southern latitudes and that are transported into the Arctic by the wind, by the rivers, and by the ocean currents. And then we saw, of course, that these chemicals were accumulating in the food chain, from plankton to fish to seals, and then up to humans eating this. And that was what we called back in 1997 the Arctic dilemma. People living in the clean environment, hardly use of these chemicals, are more exposed than people living at the southern latitude. So that is what AMAP has followed over the years in close cooperation with UNEP and the establishment of the Stockholm Convention to try to reduce the use and discharges of the chemicals. So we have tried to follow then what we call the classical contaminants, the PCB, polychlorinated biphenyls, an industrial chemical, the DDT, famous against malaria and its breakdown products, and other chemicals, in addition to heavy metals like mercury and radioactivity. So we have quite a long trend observation here. And this year we have just released a new report focusing on what you can say today on the human health, on the trend of the classical contaminants, and on radioactivity. And I guess that Jim will speak more on the health part a little later. So we see some positive signals that the radioactivity is reducing. We see the Fukushima accident in Japan has a very, very small effect on the Arctic. The transport is very slow. And we see the decrease of the old sins from the testing of the nuclear weapon. We can still see them, but they are reducing. On the persistent organics, we see reduction in some of the classical ones. But the picture is not clear everywhere. Some places, there's still levels are stable. In other places, goes down. And then we see some of the new chemicals, they are increasing. Some of the new chemicals that have more or less the same behavior as PCB and DDT, flame retardant products and other chemicals from industry, they are increasing. So the picture is a little bit complex here. And then on top of this, we have the climate change, and AMAP has been following the climate change over the years. We had the Arctic Climate Impact Assessment that was released some 10 years ago. And we are following up that with new reports, and we try to look into the combined effects, an area where we have rather little information from science. What are the combined effects of several stressors? Persistent organics, metals like mercury, and other activities. And then you have the climate as a primary driver. So since today you have a focus on the climate, we see a clear warming of most of the Arctic, and we see an increased melt. So that means that a part of the contaminants that had precipitated over the Arctic ice and snow over the last 50 years, they're now released again. They're re-released, a remobilization. We also see a remobilization further south because of increased fires. When we have the forest fires and also when the farmers are burning agricultural land, pesticides that may stay in the surface of the land area and in the trees are remobilized. So we have some very interesting observations from Svalbard where we could trace the remobilization of PCB and the radioactivity cesium-137 from Ukraine. And it took only a few days because of the wind direction was blowing north, and then we could observe it at the atmospheric station in Svalbard. So this again shows how fast things are acting into the Arctic if something happened further south. So that's one of the things you see of climate change is a remobilization of old sins, both by melting snow and ice, releasing in the local area, and then from further south with the burning of forest fires and agricultural land. But still, there's a lot of questions here of what this is. In addition to that, we see that with the increasing temperature in the marine area, you can see a change in some of the species, all the way down to plankton. And when that happens, the food chains might be affected from the smallest plankton up to the fish and also up to the seabirds and others. So we have seen some observations around Svalbard area that some of the very nutrient plankton that has a high content of fat or lipids, they love to be in the cold water. So as the water is increasing, you've got species with lower lipid content. And that's a big question that we try to see, what does that mean for the species and the food chain that is we have now in the area. Another question we have is the ocean acidification. It's not directly linked to the temperature, but it's linked to the same source, the carbon dioxide. When the CO2 increases in the atmosphere, more carbon dioxide is absorbed in the ocean. And again, we have this paradox that in the Arctic, cold water can absorb more CO2 than warm water, meaning that the Arctic Ocean may go acidic faster than other areas. And that is seen in the first report, that in some of the areas, not the whole Arctic, but in some areas, we see that we are facing a critical situation, maybe within a decade or two. Then this may affect some of the plankton, important for the food chain. And today, science cannot tell what will happen with these species. Will they not disappear? Will there come another species in that will take the place so there will be no effect on the food chain? We can't answer that question. So the picture is quite complicated. You have a complicated question here. What are the combined effects of climate change and contaminants? So where we are today, we have some answers, but we have more questions. So that is the big focus of AMAP today, is to come into this and see what is going on here. What may be the scenarios? Well, we have the International Climate Panel. They have made these scenarios, and we try to see how will this affect the Arctic, with an increase in temperature and increase in melt. How will that affect the ecosystems and the people living in the Arctic? The fishing, other industrial activities that are important for the North. And that is the work we are calling adaptation to a changing Arctic, where we try to look into the combined effects of several drivers and we are looking into 3 pilot areas. And the Bering Sea, Chukchi Sea is one of the pilot areas, where we look in not only the marine food chain, but also the terrestrial, and see how is this interacting. And that report is planned to be ready to the ministerial meeting here in the U.S. For the Arctic Council in 2017. It's a challenging job because no one has tried to do this before. We try to have people from different science and indigenous people and local people to work together and see what will be the effects here and how do you adapt to this. You have to adjust and adapt to the new situation. So that's a fascinating area, but also quite difficult to handle. Yeah, I think that's an overview of what we're doing. Normally I spend 3 hours to talk about it when I'm teaching the students at the universities. So if you have questions around the table here, that's, immediately, some reactions?
I think she does questions after.
After, okay.
Okay. So for all of our participants who called in, if you do have some questions, jot them down if you think you might forget them by the end of the call, because we will have time then for questions of all of our speakers. So thank you, Lars Otto, for setting the stage and introducing the work of AMAP. And now it's my pleasure to introduce Dr. James Berner. And again, he does have slides, so please take a moment to get those from our website at akaction.org. And he will be saying next slide periodically to help you follow along. Dr. Berner has practiced medicine in the Alaska Native Health System since 1974. He has been in the Human Health Advisory Group of the Arctic Monitoring and Assessment Program since 1999. Dr. Berner was co-lead author of Human Health, Chapter 15, in the 2005 Arctic Climate Impact Assessment, and he was appointed in 2005 to 2008 to the National Academy of Sciences Polar Research Board. Dr. Berner is certified in Internal Medicine and Pediatrics and is the Senior Director for Science in the Division of Community Health of the Alaska Native Tribal Health Consortium. Welcome, Jim. You may go ahead and begin.
Thanks very much, Diana. This morning I'm going to take a quick tour through what we know about the health effects of the compounds that Lars Otto has referred to that we're all monitoring. And here in Alaska, we do have a human biomonitoring program that is part of the circumpolar human monitoring program to look at trends and health effects from the contaminants that he's talked about. A new one is due out this year, and an update to everything I'm saying today will be a part of that new health assessment. And I spoke with Lars Otto just a few minutes ago, and he says this will be out probably before the end of the year. And it'll be online, free, so anyone that's interested is invited to view it there, download it if you want. Next slide. Can I advance it, or do you?
Yeah, if you want to do it.
No, go ahead.
Yeah.
All right.
So everybody will be advancing it on their own from their own computers.
Yes, I'm just talking about right here in the office.
Okay, I'm sorry.
That's okay. We've got it all worked out.
Okay.
So the first slide here talks about the characteristics of the Arctic population and what makes it so difficult to study, which Lars Otto has referred to. One of the a few of the factors are up here. This exposure is food chain exposure for the most part. The highest contaminant burdens in general are in the marine species, like Lars Otto said, that are at the very top of the food web. And if you want to think about it that way, the very, very top of the food web in the Arctic is the breastfeeding baby. Nothing feeds off the top predator, which are humans, except breastfeeding babies. The terrestrial species, caribou, muskox, are generally herbivorous, and their levels are much lower. The large, long-lived carnivores, like polar bears, for instance, or freshwater fish, like pike, may also accumulate large amounts of contaminants, and the pike especially can accumulate fair amounts of methylmercury. Next slide. Continuing a little bit about the exposure characteristics, as Lars Otto's mentioned, there's a wide variation in ocean and atmospheric transport mechanisms in the north, and that's how these things get here. And so the seawater levels of these contaminants and metals vary widely throughout the Arctic. And the other thing that contributes to this are the really rapidly changing socioeconomic conditions and the messages we get from television and other kinds of media that make Twinkies seem a lot more attractive than, say, smoked salmon. Next. So when we come to the analysis part of this, one of the problems we have statistically is that we're studying very, very small populations. And the more you have from the standpoint of samples, the better your statistical power is. And in the north, we have to work a long time to get a significant statistical group of almost any exposed population. The exposure is chronic. It starts with conception, and it is a low-level exposure for the most part. A lot of what's in the literature is from industrial accidents, huge exposure levels, and they don't translate into what's seen with the same compound at a chronic low-level exposure. They may be completely, and usually are, completely different effects. And most of these laboratory toxicology studies are single-agent studies, but exposure in the North Country by food is always a mixture, always, always. You never see just one compound unless it's some kind of an accident. So a lot of the accidental exposures in the human toxicology literature just aren't very useful. Often they'll give us a clue as to what the fatal dose is of that single compound, but that's not really what we see in our studies. Next. So the other piece that's harder to understand sometimes are that causal relationships for single agent exposures. We have a little bit of that data in the human toxicology literature. Asbestos is an example. Asbestos exposure is known to be the sole cause of the malignancy mesothelioma. Okay, so there's a very clear causal exposure. PCB and a skin problem called chloracne, very clearly associated, and that's another high-level exposure with PCB. Lead neurotoxicity has been extensively studied. We understand that pretty well. Mercury and Minamata disease, an industrial exposure, not from a natural source. We understand that pretty well. But mixture exposure is far less often successfully associated with an outcome. One of the real successes is tobacco smoke, which has hundreds of compounds and is very clearly carcinogenic. And we have the goods on that, so we know that. And that's a mixture, but the outcome is, when you go down the list of tobacco-associated conditions, pretty soon you get into conditions that can be caused by other things, but are commonly associated strongly with tobacco smoke. So those associations are still very useful because we can use those in risk calculations. But it's not something that we can say X causes Y. We can do that with a few things, but not very much. Next. So one of the problems with mixtures is that you can have very low, pretty much harmless levels of things that individually are not associated even with laboratory effects, but together they act in a way that they don't alone. So a mixture is potentially more dangerous than any one of the single compounds in the mixture. Not always, but sometimes. And the way that generally works is two different toxicants can have effects on the same set of chemical reactions in a cell by different mechanisms, and the effect can even be additive. So all these things have to be looked for, and first you look for them in animals, and then you begin to wonder if they're there in humans, where it's a little bit harder, because we can't extend an animal or a single cell exposure to an intact human where we have lots and lots and lots of metabolic defense mechanisms, thank goodness, because we're exposed to a lot of these things on a daily basis. And in general, we deal pretty well with them. Next. So the effect studies that are well published in the North have a number of problems. One of the classic example are the persistent organic pollutants, and I've used the abbreviation POPs and metal effect studies from two populations of children that have been studied very carefully. One in the Faroe Islands, studied from a perspective of mercury exposure, and the other one in the Seychelles Islands, another fish-eating population with mercury exposures just as high as the Faroe Islands. And the Faroe Islands show detectable neurodevelopmental effects associated with mercury. The Seychelles Islands, at the same level of exposure at the same time in pregnancy, do not. And the difference here may be what we're talking about with mixtures of toxicants. Compounds like PCBs are usually found in the Faroe Islands, fish and pilot whale, and they're not found in the Seychelles Islands. So there's the issue of not only are they genetically very different people, the Seychelles Islanders, from the Old Norse inhabitants that are pretty genetically similar in the Faroe Islands, they're very different, and they may react in different ways to things that we still don't understand. So genetic differences and exposure differences can complicate, say, simple mercury toxicity studies. Next. So lifestyle, how many people in the population, what percent of them smoke, what percent of them have other kinds of drug issues, their general economic status, which speaks to their nutritional status, and other issues are confounders in these studies and have to be accounted for and are not always. Next. So in remote isolated communities where we're doing where we're looking at children born with a certain prenatal exposure that we're interested in seeing the effects on development as infants, often, like in Alaska, for instance, we don't do these studies. Other countries do, but we don't. And the reason is, in the Yukon-Kuskokwim Delta, where our monitoring program is, you can't reliably get a public health nurse out at exactly 6 weeks post-birth to any child, unless they live right in Bethel. So the variation when you assess development of the time you assess it is critical, because a 7-month-old is different, real different than a 6-month-old. And if you are assessing a 7-month-old by 6-month-old standards, and you say, well, this is normal for a 6-month-old, then the 7-month-old is really a little behind where they should be. So it is a very difficult thing to adjust studies of development for prenatal exposure and say we have a significant delay in motor function and whatever, fine motor skills. It gets very, very difficult to do. And when you begin to look at intelligence in children, then the language they're brought up in, what a 2-year-old hears at home, and the way they get tested with often tests that aren't normed for an Inupiaq-speaking child, can be misinterpreted. So it's a tricky thing to do. Next. So we have lots of studies going on, and I don't think I'll go into all these studies, but just a little bit of the problems you get are related to variations in diet from one place to another, variations in the time of the year when you draw your blood, which depends on, the diet then may be different than in the summer if you're looking at exposures to certain things. So it's not easy doing this in an Arctic population that's small and scattered. Next. So the health effects studies are complicated by the fact that they all are dealing with mixtures. They're all dealing with multiple confounders. They're all dealing with marine subsistence diets or freshwater fish diets. And very few of them have more than one observation over time in the same person. Like almost none of our monitoring studies in the Yukon-Kuskokwim Delta follow the same woman over the whole 16 years. Each cohort enrolls people who are pregnant then and who want to join. So while there's a very great similarity genetically and from the diet standpoint, which is very valuable, they are not the same people. Next. So PCBs, there have been lots and lots and lots of papers on the results of PCB exposure, and there are more coming out, or more of these will be described in detail in the new Arctic Human Health Assessment, which is coming out. But in infancy, not in all populations, but in some of them, there are mild abnormalities in muscle tone, reflexes, and activity level that you can see starting at 3 or 4 months and may still be present at up to 18 months. That hasn't been true in all the studies, but it has been in enough so that it's now published. Prospectively studied infants with the highest exposure to PCBs do have predictable neurocognitive levels. Now, a lot of these are children from those early studies where there were industrial accidents. Most prenatal low-level exposure studies don't show anything. And a good many of these are attributable. The attributable studies that show something do not seem to be affected by, in fact, they may be mitigated by breastfeeding. They're most significant in the group that isn't breastfed. Next. The organochlorine pesticides, people lump these studies into one group because it's very hard to get individual exposures here. DDT and toxaphene and Myrex and all the others, and there are half a dozen of them, have all been looked at, and unfortunately, it's really difficult to find any consistent impacts. Most of the effects are in low exposure populations, and in the Arctic, they're always found with PCBs and mercury. So it's hard to know exactly what to blame, but maybe the mixture's to blame, and we don't know the answer to that. We would rather nobody was exposed to any of this stuff. However, one of the things that's interesting is what we see in adults who have levels, we don't know how long they've had them, but they have them when their blood is drawn. This is in the National U.S. NHANES study. And both the organochlorine pesticides and PCBs are strongly associated with an increased risk for type 2 diabetes, independent of obesity. So a thin adult with high levels of these things is still far more likely than an obese adult without these to have diabetes. And that's a very interesting finding, and it's significant, and it's one that's been found every place it's been looked for. So it's there, and it may be related to the fact that all these compounds are inflammatory in humans. They're all inflammatory, and type 2 diabetes is one of those diseases that's associated with inflammation. That's one of the causes of insulin resistance. Next. The brominated flame retardants, like Lars Otto said, are they're not new on the scene, but we've newly recognized them in our analyses. And we have pretty good data. One of the questions we asked here in Alaska is, are these associated with subsistence food? And the other new compound are the fluorinated compounds. And, excuse me, and those compounds are appearing in about the same amounts in blood as the brominated compounds. U.S. women, well, U.S. men and children too, have the highest levels in the world of these compounds. And it's because they were regulated into infant clothing and furniture covering and furniture stuffing and curtains and rugs, because it was thought that they reduced the rate of spread of flames. So they have, Alaska Native Yupik women in our study have the same levels as U.S. women in the lower 48 in the childbearing age range. This is not from subsistence food. We don't find it in the salmon, and we find very, very low levels in the marine mammal predators. So in the U.S., in Alaska, probably in the lower 48, people are getting this from their indoor environment. And it is a well-established component of house dust in just about everybody's house. And it's also commonly found in things like lipsticks, computer keyboards, plastics of all sorts. So we're exposed to it a lot. Health effects from this are not as clear because everybody's got it, and it's hard to compare it with a population that doesn't. It probably has all the same risks at pretty much the same exposure levels as the PCBs, because structurally, chemically, they're very similar. Next. Now, the perfluorinated compounds are different. They're highly persistent, but they aren't lipid soluble. They're attached to protein. And so it is one of those things that we measure in plasma, but not the lipid fraction, not the fat fraction. And they're present in marine species in just about the same levels as we see them in the women who eat them. So this is associated with subsistence food. And the brominated compounds are not. Now, as far as health effects go, these are things, interestingly enough, that seem to be associated with an ability to downregulate, to interfere with the production of antibodies. It isn't that you can't produce antibodies. It doesn't give you an immune deficiency. But it's very clear, it's a pretty solid association that high levels of these are associated with lower levels of responses, antibodies, to say the childhood vaccines or adult revaccinations. So you still get antibodies, but they're at a lower level. And there are a few people who may not get the same antibody protection because of that lower level. For the majority of the population, it hasn't been shown yet to result in an increased likelihood of infection with a vaccine-preventable disease. But that's still ongoing research. Next. Mercury, we know a lot about mercury. It's primarily a neurotoxin, and the developing brain is by far the most sensitive stage of neurotoxicity. Changes in heart rate variability and the ability of your brain and nervous system to control your heart rate have also been documented. But that's not always a solid relationship to prenatal exposure. That may be, mercury is not as long-lived by a long shot as any of the organic pollutants. So it has about a 3-month half-life rather than 10 years. Next. On mercury, from the standpoint of mercury exposure, there have been some long-term prenatal studies followed up in Canada, Greenland, the Faroe Islands, also in New Zealand, and other countries in the Seychelles Islands. And some comparable neurodevelopmental testing has been done, and clearly the effects are detectable in highly exposed children in Canada and the Faroe Islands, but not in the Seychelles Islands. So the other fellow travelers with mercury may be having some effect on those children. Where there are lots of persistent organic pollutants in the same creatures that have the mercury, there may be more of an effect. Next. And we just talked about this, and it needs more follow-up. Yes, next. So there's some mitigating factors that have come out of these studies too, and it's one of the reasons that from the start in our monitoring study in Alaska, we've studied micronutrients along with the toxic elements that we're testing for. And breastfeeding reduces the impact of PCBs in breastfed children. They have far fewer signs exposed at the same level as non-breastfed children. A big, important protective factor. So what we don't want to do is tell a group of women who are on a subsistence diet, and you know they've got blood levels of these compounds, don't breastfeed your babies because the breast milk has it. In fact, the breast milk has things that we don't understand very well that mitigate this. So they're the most important group to breastfeed, probably. But the other thing is that higher cord blood levels of omega-3 fatty acids also improve cognitive and motor development in Inuit children. Very solid, marked effect. And this is something we'd really like to encourage because there are sources of omega-3 fatty acids that are not associated with top marine predators. So you can get it from other sources, and you should. And then there are some age will mitigate some of these factors that are present in early infancy as well. So, for instance, mild blood pressure elevation associated with prenatal mercury exposure in the Faroe Islands disappeared in children by the time they were teenagers. And other things may as well. That's been the case in the POP studies in the lower 48 as well. Next. Okay. In conclusion, we know lead and mercury are bad actors, and we understand that really well. PCBs have well-documented effects, but they're best seen in very high exposure levels, and they're very difficult to separate when they're seen in mixtures with other compounds, and particularly the metal toxins. Organochlorine pesticides are always seen in mixtures. It says usually, but they're always seen in mixtures in the Arctic food chain and in the residents. And effect studies have been very difficult to show clearly. Now, mixture toxicology by us folks that are studying it is very poorly understood, and it needs a lot more attention paid to it. And we're trying to do that, but still, it's an ongoing struggle. And I've got a couple of other slides here that are, okay. Now, there's a reason why we do these monitoring studies, and this is one of them. And this isn't St. Lawrence Island. This is just north of St. Lawrence Island on the Russian side. And this is from some work that the Alaska Native Tribal Health Consortium has done. Mike Brubaker took these pictures, and he was helping these folks get a basic understanding of hazmat exposure and how you can handle these barrels. Maybe not best, but with the stuff they had available, handle them. Now this is just one picture because there are many square miles of these barrel dumps. And I've got pictures that I didn't bring that show the barrels erupting from the permafrost. And so what happens when that happens? Next slide. Yeah, this is a colleague pointing to a line of oil seeping out into the ocean just below the tide line. That's what happens. That's the reason we have to monitor. Can't quit. We can do it more efficiently, but we can't quit. Next slide. So we've talked about that stuff, and this is just the references. So people that are interested can look things up. So I'm done.
Thank you, Jim. I'm going to just move on to our next speakers so that we have some time towards the end for questions. So thanks again, and we will be sending some additional resources out after the call for people who'd like to learn more. Our next two speakers are from St. Lawrence Island. Merle Apasingok graduated from the John Apengaluk Memorial High School in Gambell in 1984. As a junior and senior, he participated in an international academic program studying global warming, radioactive waste, genetic engineering, and overcrowding in prisons. Merle served 22 years as a board member for Sivukak Incorporated, a state-chartered for-profit village corporation. Merle and his wife, Rona, have been working for Bering Air, a commuter airline based out of Nome, since June of 2000. And providing weather reports and observations to the airline are some of his duties as a village agent. Merle has been hunting since he was a child and is currently a registered whaling captain in the Alaska Eskimo Whaling Commission. Welcome, Merle.
Thank you. Good morning to everyone. I would like to start off with some observations, including myself, but we usually communicate with one another, we being hunters who are out there, as we have to help each other going out and we have to help each other coming back home. So in the, I believe in the mid-1980s, I observed that while going hunting, the tundra, the topsoil and the vegetation started to fall, just falling down and creating huge dips or craters. And I didn't really think too much of them, but later I was thinking perhaps the permafrost underneath the tundra, the topsoil, melted to create these craters. And then my uncle, again in the 80s, Preston Apengaluk, we were handlining for crabs out on the sea ice, the shore fast ice. And out of nowhere, he told me, Merle, I noticed that our water is warming. And I remember that cold day, how he can notice our water warming. I was befuddled a little bit. But many years later, I see his observation later. And then one experienced sea hunter who walks out onto the ice and he hunted many, many years. His name is Leroy Coolican. And again, out of the blue, he told me, your generation is going to experience more dangerous boating. You guys are going to quickly go out, get game, and quickly come back in because of these sudden storms. And many years later, we see his prophecy come to become true. And that's what's happening today, is more dangerous weather and sudden storms. And one other observation is from my first cousin, who, let's see, back in nearly 15 years ago, his name is Ivor Campbell. He's currently a IRA councilman. And in January, there was a winter storm out of the southeast, and this created a lot of warm weather and generated Pacific swells that pounded our shorelines in January to a point where there were no more pressure ridges, but just gravel. And it was raining and melted all the snow, most of the snow in the community, and all the snow on the shoreline, all the ice on the shoreline disappeared to a point where lots of sea plants that we gather, I think there's about 20 sea plants that we gather from these storms, the aftermath of these storms. There was about 20 of us picking them on the shore. And I told my cousin Ivor, perhaps if our forefathers woke up today, they would not know what month of the year it is. He responded by saying, if our forefathers woke up today, they would know exactly what month of the year it is, because when he was a child, he stayed with his grandfather often. And during these times, his grandfather's peers would come over for tea and stories. And one of those stories that stuck out on his mind was he heard them say, one of these days in the future, we will not experience winter out here anymore. But other places who never experienced winter will begin to experience winter. And he went on to tell me that they said this prophecy has been from way, way back. And it's been passed down from generation to generation. And those are the observations I wanted to start off with. And sometimes last week we had a teleconference with ACAT, and in one of those discussions, Eddie Ungot, the president of the Native Village of Gamble, I would like to share what he said is these fluctuations in the permafrost, the melting permafrost, and the higher temperatures creates a situation where the permafrost is going to fluctuate more. It will melt, and the next cold season will freeze it back up. And that, combined with Leroy Kulikan's observation of sudden storms, we have experiencing more storm surges here in Gamble, I think the last 20 years. And this combination of storm surge and the fluctuating permafrost will create migration of pesticides and DDTs and here in Gamble, since it sits on a gravel spit and surrounded by three sides water. The northern side is covered with the Bering Sea, the west side's Bering Sea, but our southern flank is covered with the Troutman Lake. So Eddie Ungot was concerned about the migration of these contaminants left by the military, as Gamble was the site of a fairly large military base. So, and we have seen my Uncle Preston's observation from the 80s. Now, everyone knows, almost everyone knows that the water level's rising, and the warmer waters are creating our ice to thin. The last time the multi-year glacial ice we call Gulusik arrived in 1999, And these blue ice glaciers, we haven't seen them since then. I remember this clearly as a phenomenon, an early winter phenomenon called pyre in our language, is a combination of many things, but pyre is one of what used to be 64 names for ice here on St. Lawrence Island. But that has been revised to 99 documented names for ice. But this one name we haven't seen since 1999. That's pyre. And the Kulusik, those two names we haven't seen since 1999. And the pyre is a storm-driven waves packing the slush ice onto the shore, and some of it freezing to a point where seals are trapped. When the slush ice gets so dense, the seals can't go back out to deeper water, so they're trapped within this cocoon or of slush ice, where they can't penetrate out. But the only way they can do it is they go up to surface. And early morning, I took off to Akidlungok Bay, just northeast of Gamble, and I noticed there were many seals popping up just right there, and they weren't afraid of me. I realized that they were trapped. And some of them were dead. Some of them were bloody. Some of them were eaten. And I didn't know what was going on. And I went back and got my 6-year-old son and my brother. And we went back out, and I let my 6-year-old son get, he got 4 seals. Very, very happy day. As that's about the age that we start going hunting and get immersed in the hunt itself. And we realized later that those seals were caught by a polar bear. And those polar bears follow the seals. And also another phenomenon called Kulusik Katautuku occurred. It was the glacial ice poured out the seals is a phenomenon where there's many seals. Before the ice flows get in, the glacial ice gets out first. That's an exciting time for the community because many seals are abound for winter storage. So we noticed that warming water has created the ice flows to have less integrity. Ice flows, these huge ice flows are also they're little ecosystems on their own. Because when they hit Gamble Point, the current takes the other side of the ice. Still, the current takes them south, but the tip is anchored on Gamble Point, and open water starts to form downwind of them. And these huge ice flows start to turn while still anchored. And this little channel funnels migrating animals right to Gamble. And where that also is a very good time for hunting. It's like a natural way of herding animals. These ice flows herd animals. Polar bears will walk along the ice flow northward, and they'll hit gamble. Many polar bears have been caught. Many walrus and many seals have been caught and fed the community. But nowadays, these ice flows have less integrity. When they hit the gamble point and the current starts to take them the other side, south, and they crack right in the middle without creating this open water, without creating this funneling effect to herd the animals.
Thank you, Merle.
Yes, I will close with that.
Yeah, unfortunately, due to time constraints, I do need to move on to Vi. But I just want to thank you for sharing your firsthand observations of climate change and also the stories of people from the island that were predicting it. And I wish we could hear a lot more from you, and I'm sorry that time is limited. So now I'd like to introduce our final speaker for today. Vi Wahi is a bilingual Yupik who was born in Savunga on St. Lawrence Island. Although her family moved to Nome, she grew up in both communities, traveling between Nome and the island throughout her childhood. Vi has been working with Alaska Community Action on Toxics since 2002 and currently serves as ACAT's Environmental Health and Justice Program Director. Welcome, Vi.
Good morning, Igam Sekai Vikamsi. Thank you for giving me this opportunity. And I'd like to thank Lars and Jim and Merle, who were ahead of me. And I enjoyed all their presentations, and what I found very important and interesting was Merle's local and elder knowledge that he shared of the observation of climate change. And what I had to say, Lars did mention some of that. So I'd like time for discussion and questions. I want to say the concerns that we have as local people is the sequestered tops, the glacial ice, permafrost, and sea ice from the pops that arrive in the Arctic. As they melt, that's going to be another source of exposure. On St. Lawrence Island, we've had our own community-based project since 2000, looking at PCBs, pesticides, heavy metals, solvents, also massive fuel spills from local sources like the military contamination and distant sources like the global contaminants that were talked about earlier. So our people have been disproportionately harmed by the military contamination and the pops that we've looked at. We've looked at them in our environment, in our groundwater, sediment, air, but also in our traditional foods. We looked one batch at PCBs, pesticides in our traditional foods, and another in the heavy metals. And we found those to be alarming in the marine mammals, the PCBs, at levels we should not be eating the bowhead whale, walrus, and seals, blubber, and rendered oil, which are very important foods. So, and this, another route of exposure will be from the global warming. So as a result, we're some of the most highly contaminated population on the planet because of our reliance on our subsistence foods. And we are seeing cancer crisis today and other health disparities never seen before, until after the military left. There was one study that was done in University of Alaska Fairbanks. We only had one cancer case in the 1950s. But I just wanted to share that as these pops are being released from sea ice, permafrost, and glaciers, that's another route of exposure to populations like mine. And I'll be very brief, and that was it.
Thank you, Vi. Thank you so much. Now we'd like to invite questions and comments from our participants. So if you'd like to ask a question, please press *2 to unmute your line, and please also state your name and affiliation. We also ask that you try to be relatively brief so we can get to a few questions. We're going to go over just a little bit, but I know that people do need to get on to their next meetings and everything. So thank you very much, and we now invite some participation from the people who called in. Don't be shy. Just press *2 to unmute your line if you'd like to ask a question of any of our speakers or make a comment. Well, if we don't have questions, I would just like to give Lars Otto an opportunity to make any summary. I know your presentation was quite short at the beginning. You were leaving a lot of time for everyone. If you would like to make any final remarks.
Well, it's been interesting to listen to this presentation. As you heard, Jim gave a more detail of what we now see coming up on the human health part here. And the reports are available on AMAP website. There's a summary for policymakers with the recommendations we have made to the politicians, what they have to do now. And there are more reports coming up in the years ahead. I think it's very interesting to see how important it is to work together with the local and indigenous people of the north and to use their observations to get the science, to see how you can approach the scientific strategy so that you analyze the right area here. Mm-hmm. There's a lot of questions we can't answer today because we haven't looked into them. And as Jim was into here, to work with the small populations of the north, traditional epidemiological study is not easy. You have to have much more people if you should be able to say anything for sure. So you need to develop new methodologies on cause-effect relationships. And one of the big challenges today is that we see new chemicals that are accepted for use are ending up in the Arctic. To me, that tells that the test requirements of chemicals is not good enough. There are holes in the test system that allow chemicals to go through. And for sure, many of these chemicals are not tested in mixed products. So there's a lot of knowledge we don't know, and to some extent we are using the environment as the last test area. So that's a concern I have, is that the test criteria that are applied for new chemicals is not strict enough to protect the people, especially people that are living off the nature, because they will be the first one to pick up these chemicals. So that is a challenge for people of the north to bring up and to get legislations in place. That's it's been interesting to be here today and bring with me some good, interesting things to the further discussion in AMA.
Thank you.
Hello, this is Larry Duffy from the University of Alaska Fairbanks. Hello, yeah. So Larry Duffy from the University of Alaska Fairbanks. I have a question for Jim Berner. He pointed out that most of the risk comes from the marine, at the moment, from the marine food chain. And I was just wondering, since the Arctic has a lot of areas that, are not coastal, what's his opinion of monitoring river systems and trying to do a more broad assessment on the chemical species that he's been talking about?
Well, this is Jim Berner. That's a great question, and I didn't have time to address it, but it is one of the that we've recognized in the Human Health Assessment Group. And the consortium, the Alaska Native Tribal Health Consortium, has just started in the last year a community-based monitoring program that isn't restricted to coastal communities, that looks at sources that are not things we usually think about. For instance, tundra ponds that are either traditional or primary source water for villages is, exposed to a longer warm season now, which means that the mercury deposited in it from the air or that gets in from melting permafrost, because there's a lot of natural mercury in Alaska, there's a lot more time for that to be methylated by resident bacteria in those water bodies. And in our monitoring program, we're funding communities to test that water to look and see if they're being exposed to water levels of methylmercury, for instance, that they've not seen before and haven't been an issue. And the other thing are the bacterial and algal toxins that are freshwater issues all over the lower 48 in the summer. I've got a great slide that shows a picture of a cyanobacterial bloom next to Kotzebue. So that's not an area where it's ever been seen before, but it is now. So that is another thing that we need to look for. And we need to look for it in the water, and we need to look for it in fresh water as well as estuarine water. And we need to look for it in the bivalves that both the seals and walruses and people eat, because they're the filter feeders that are really the sentinels of the system out there near shore. And we're going to be testing both of those things in this new monitoring program we have that's not aimed at humans. It's aimed at the subsistence species that they eat.
Oh, that's great.
Thank you. Thank you.
I have a question for Merle.
Yes, go ahead, Mai.
These observations that you shared with us, have they been documented?
Not really, but we're still pretty much oral history oriented, and some of these are documented in the school's bilingual bicultural program through three books called Lore of St. Lawrence Island.
Thank you. I believe we really are out of time now, but I do want to thank all of the participants and all of our speakers for being with us this morning, sharing so much knowledge and observations. We really appreciate your time. There will be a recording of today's call available on our website, and we'll notify you when we've posted that, and as well as providing some follow-up resources. So to all of our speakers, if there's anything that you think our listeners would like to look at as a resource, we've posted some things on our website, but we can continue adding to that. So please go ahead and send those my way. If you have additional questions or comments, please feel free to contact us at 907-222-7714. You can also email me at diana@akaction.org. And thanks again to everyone. Have a wonderful day.